Assalamu alaikum warahmatullah. Hi everyone. Today in this video I'm going to discuss with you about one of the topics of the probability, which is known as the conditional events. First, let's start with the definitions of the conditional events. So the meaning of the conditional events in this situation is when an event occurs with the conditions that another event has occurred, then the event is a conditional event. For example, the event that a girl is choosing knowing that the students wear spectacles. And secondly, if let's say that we have two balls are taken from a box containing several red and the blue balls without replacement, then the event that getting the second ball depends on the first ball. From the first example, we can see that there are two events happen in this case, in this example. The first event is about girl is chosen, and the second event is about students wear spectacles. So we can see that the probability of getting a girl is chosen is depending on the probability of students who wear spectacles. If I would like illustrate this example in the form of mathematical form, so let's say that if I declare the first event here, which is girl is chosen, okay, is as event A, and the students wear spectacles as event B. Okay, so to illustrate this example in the mathematical form, so that I can say that in order to get a probability of girl is choosing, which is A, given by knowing that the students wear spectacles, we can say that PA is given by B. In other words, we can say that conditional probability is about the probability that an event will occur given that another event has already occurred. So let's say that we have two events A and B in a sample space. So we define the conditional probability of A given by B as PA. So we have a vertical line B, which is equals to PA intersect by B over PB. And as we may concern, PB must not be equal to 0. And this PA, and we have a vertical line B, it is read as the probability of A given by B. Let's start with first example. The event A and B such that probability of A is equals to 1 over 4, probability of B is equals to 1 over 3, and probability of A union by B is equals to 5 over 12. Find first probability of A intersect by B, second probability of B given by A. So let's start answering the first one, probability of A intersect by B. So as we may concern, the probability of A union by B is equals to 5 over 12. So we can say that the first one, the probability of A union by B will be equals to probability of A plus probability of B minus with A intersect by B. So this we have a value of PA, which is 1 over 4, plus with PB is equals to 1 over 3, and then we minus with the probability of intersection, which is, this is actually what we're looking for, probability of A union by B, and we have the value of A union by B, which is 5 over 12. So by simplifying of this value, calculating all of this value, we're supposed to have probability of A intersect by B, which is equals to 1 over 6. Then the second one, which is we are going to look at the conditional event probability, which is we have probability of B given by A. This is actually equivalent to probability of A union by B divided of probability of A. okay, using the formula of conditional probability. So these intersections, we already have the value, which is 1 over 6 divided of A, probability of A, which is 1 over 4. So this is 1 over 4. So this will be equivalent to, after we simplify, we're supposed to have 2 over 3. Let's continue with example 2. A and B are two events such that PA is equals to 1 over 3, PB is equals to 1 over 4, PA union by B is equals to half. Find A, PA intersect by B, B, PA intersect by B complement, C, PB is given PB given A, D, PA given by B complement, and lastly we are looking for the probability that exactly one of A or B will occur. So let's start answering the first one, which is A. We are looking for probability of A intersect by B. So we know that in order to find this, we are going to use the formula of A union by B, which is equals to PA plus PB minus with probability of A intersect by B. By simplifying of this, we're supposed to have A intersect by B is equals to PA plus PB minus with PA union by B. So by putting all of this value, we're supposed to have 1 over 3 plus with 1 over 4 minus with half. Then this is actually equivalent to 1 over 12. So now B, we are looking for the probability of A intersect by B complement. So this is actually, we have to use a Venn diagram in order to solve this, because we have a B complement, if you still remember on our previous video. Okay, so now let's do the Venn diagram. Okay, so let's say that we have a Venn diagram. Then let's draw two circles, which is representing of the event A and B. So now we're looking for A intersect by B complement. So I'm going to draw a region for A first. So this is actually the region for A, and the region for B complement, which is outside of the B. So if you can see from here, the most intersections of the regions that we're looking for is actually in this part. Okay, which is, this is actually equivalent to probability of A minus with probability of A intersect by B. So since we have already the value of probability of A and probability of A intersect by B, so this is actually supposedly intersection. Okay, then here PA is equals to 1 over 3 minus with intersections of AB is 1 over 12. So after calculating this value, we're supposed to have 1 over 4. Okay, now let's proceed with C, which is we have B given by A. So we're looking for C, probability of B given by A. So this we're going to use the formula of conditional probability, which is will be equivalent to probability of A intersect by B divided of probability of A. So by putting this value of A intersect by B, which is 1 over 12, divided by PA, which is 1 over 3. So this will be equivalent to 1 over 4. And lastly, we have D, which is also the conditional events of probability of A given by B complement. Okay, so this will be equivalent to probability of A intersect by B complement over PB complement. So remember, we already have this value we just calculate just now, which is this is actually equivalence to 1 over 4, and the probability of B complement, which is equivalence to 1 over this is actually equivalence to 1 minus PB, okay, which is we're supposed to have 3 over 4. So therefore this actually equivalence to 1 over 4 divided by 3 over 4. So this will be equivalence to 1 over 3. And lastly, let's take a look at the last questions, which is E, the probability that exactly one of A or B will occur. So C, so what we're going to do is we're looking for the probability of exactly one of A or B will occur. So this is actually equivalence to probability of A union by B complement plus with probability of B union by A complement. Okay, so we already have this value of A intersect by B complement, which is 1 over 4, plus with B plus with A complements. So this one we have to use a Venn diagram, just like we did for A intersect by B complements. So by using this Venn diagram, so we have the two events of A and B. So now the regions of B intersect of A complement, okay, B intersect of A complement, which is the region that we're looking for, is actually this part. Okay, whereby this is actually equivalence to PB minus with PA intersect by B. So this will be equivalence to 1 over 4 plus with 1 over 4 minus with 1 over 12. Okay, and lastly, after calculating all of this value, you're supposed to have 5 over 12. Example 3. In a college, 12% of students are left-handed, 15% of students wear glasses, and 3% are both left-handed and wear glasses. A. Given that a student wears glasses, find the probability that a student is a left-handed. B. What is the probability that a left-handed students also wear glasses? So from this example 3, we can see that these two questions is about a conditional events or a conditional probability. So how we can rectify whether this question is about a conditional events probability? The first one is the words of given. The words of given here means that we are looking for the probability of a left-handed students when the probability of students wear glasses is given. And the same thing for B here, whereby we are looking for the probability of the students who are left-handed, whereby we already have the probability of students who wear glasses. So in order to solve this, so let me just declare these two events. Okay, so let me just declare with the first events of students who are left-handed as a L. So this will be equivalence to the event that the students is left-handed, and the second event I'm just declare as a G, which is event that the students wears glasses. Okay, so now we just declare these two events as L and G. So then we're going to write the first informations that we have here, which is we are going to have the probability of L, which is equals to 0.12, and we have probability of G, which is we have 15%, which is equals to 0.15. And lastly, we have the probability of both left-handed and wear glasses, which is 3%. So this is actually equivalent to PL union by G is equals to 0.03. So now we have these three informations. Okay, now we would like to answer the first one, which is A. Okay, the questions is about, given that the students wear glasses, find the probability that students is left-handed. So this is actually a conditional statement, just like I mentioned just now, which is for A, we are looking for probability of L given by G. So this will be equivalent to, using the formula of conditional probability, is equivalent to PL intersect by G over PG. Sorry. This is equivalent to PG. Okay, so this is equals to 0.03 divided by probability of G, which is 0.15. So after calculating this, you're supposed to have 0.2. Okay, then for B also is about conditional probability, whereby we're looking for the probability that a left-handed students also wear glasses. So this is actually, we're looking for probability of G given by L. So this will be equivalent to PG intersect by L over PL. So this equivalent to 0.03 divided by 0.12, and this is equals to 0.25. Next example is about example 4. 30 mathematics professors out of 100 who are examined were found to be overweight, which is denoted by W. 10 of them had high blood pressure, it is denoted by H. Only 4 of the professors who are not overweight had high blood pressure. Find the probability that a mathematics professor will not have high blood pressure if he is not overweight. So the first one, I'm going to write all of these informations. So the first thing is that we know that we are going to have the probability of W, which is the professors who are examined were found to be overweight. Okay, this is actually equivalent to 30 over 100. And we also have the probability of overweight intersect with high blood pressure, which is, this is actually equivalent to 10 over 100. And lastly, we have the last information, which is 4 of the professors who are not overweight had high blood pressure. So this is actually probability of W complements intersect with H, which is equivalent to 4 over 100. So in this questions, we are looking for a conditional probability, whereby we are looking for the probability that a mathematics professor will not have a high blood pressure if he is not overweight. So this is actually the statement of the conditional probability. So now what we're looking for in this case is, we are looking for the probability of H complement given by W complement. So in order to do this, we're going to use the formula of conditional probability, whereby this is actually equivalent to probability of H complement intersect with W complement over probability of W complement. So by using De Morgan's rule, this will be equivalent to probability of H union by W complement divide over 1 minus probability of W, and this will be equivalent to, since we have a complement, the same thing, we are going to have 1 minus probability of H union by W divided with 1 minus probability of W. Okay, then in order to find the probability of H union by W, so what we're going to do is we're going to find the probability of H union by W using the informations of, we have W complement intersect by H, which is, this is actually equivalence to 4/100. As we may concern from the Venn diagram, if we have a Venn diagram which is illustrating the W complement intersect with H, okay, so let's say that this is actually the event of W and H. So now W complement intersect with H complements, so the region that we're looking for in this case is actually this part. So this is actually equivalence to probability of H minus with probability of W intersect by H, which is equivalence to 4/100. So it means that we can find the probability of H, which is equivalence to 4/100 plus with probability of probability of W intersect by H, which is equals to 10/100, and this will be equivalence to 14/100. And from here we can find the value of probability of W union by H, which is equals to probability of H plus with probability of W minus with intersections of them. Okay, so this will be equivalence to 14/100 plus with 30/100 minus with intersections of them, okay, intersections of them, which is equals to 10/100. So this will be equivalence to 34/100. Then since we already have this value of W union by H, then we just plug in accordingly into our this, which is 1 minus with 34/100 divided by 1 minus with probability of W, which is 30/100. Therefore will we have 66/100 divided by 70/100. Okay, and lastly we're going to have this is equivalence to 66/70, and after simplify you're supposed to have 33/35. So this will be the final answer.